Today, the call of the open road is often the cry of despair. The increase of vehicles in the nation's cities and on its highways has reduced freedom to frustration. We face a future of increasing stop-and-go travel unless the traffic engineering profession can meet the challenge. Increased population, affluence, and mobility present us with a relentless problem that is constantly making the traffic engineer's job more difficult and the task more expensive and vital to his community. But along with the bad comes some good. The professional traffic engineer is assuming an increasingly important position in the community. Someday, the chief traffic engineer may have a fancy title such as Director of Transportation Systems Management. He may control, in real time, all activities and modes related to the movement of public, municipal, and commercial vehicles. To meet this challenge, today's traffic engineer must become a pioneer. Like modern military commanders and business executives, he must learn to take advantage of the new tools provided by research and development and apply them to his problems.
It shows the predominant flow southward here in the AM peak hour.
The Sperry Rand Corporation has lived through this transition with federal agencies and industry leaders, and now is proud to be working on it with federal, state, and local traffic engineers. Sperry's Traffic and Transportation Systems Group is unique, both in organization and approach. Though part of a giant corporation, the group is relatively small and solely dedicated to the transportation field. A basic policy, strongly enforced, is that system concepts and designs must utilize the best and most economical techniques and hardware available, regardless of their source. In Sperry's systems management approach, responsibility is assumed for all tasks that make the project successful. Installation and integration of all equipment, central, interconnect, and street, staff training, maintenance service, and supportive operational growth. At its New York headquarters, Sperry engineers have assembled a typical advanced traffic control system for demonstration and training purposes. It provides the two most important new tools available to help traffic engineers meet their challenges. First, a detailed and instantaneous knowledge of traffic conditions and system performance in the streets. And second, a quick reaction loop permitting them to make and evaluate signal timing adjustments, either individually or collectively throughout the city. Here in the Sperry Center, a visiting traffic engineer can use the system as he would utilize it in his own city. Information is fed into the computer from sensors at and between the signalized intersections to be controlled. Reacting to the conditions in the streets, the computer automatically adjusts timing patterns to permit motorists to proceed with greater safety and at minimum delay by reducing stop-and-go signal situations. The system needs no operator, but it can use a coach. The traffic engineer, given pertinent data and using system displays, can evaluate improvements made by the computer, then go on from there to optimize the signal patterns. Here, the traffic engineer asks the computer to indicate overall street conditions in terms of volume, density, occupancy, and speed. Using a set of matrix push buttons, he can isolate the severest problems. He can instantaneously call up system data and then make changes manually. The system demonstrates a number of automatic fail-safe provisions. Should a serious problem arise, such as cutting off communication to Computer Central, the affected portions of the system will revert to independent, coordinated local control. The system automatically records and analyzes traffic counts as instructed and prepares technical or management reports as directed. The result? More time for the traffic engineer to address the engineering challenge. In addition, When the City Council wants data for planning or evaluating construction proposals, it will soon learn that the Traffic Department is efficiently organized to quickly provide such information. In addition to city traffic control, the Sperry Traffic and Transportation Systems Group is applying its special talents to automated surveillance, communication, and control for expressways and turnpikes. An example of this is a study underway for the Van Wyck Expressway in New York. It connects Midtown Manhattan to Kennedy and LaGuardia airports. The ADT of 122,000 vehicles makes the Van Wyck one of the most heavily traveled roadways in the world. A breakdown or accident here can tie up commuters for hours. On the New Jersey Turnpike, a Sperry-designed system will anticipate slowdowns and stoppages, balancing service on the double-barreled sections of the roadway. Reading out information from as many as 12 lanes along the road, the system will automatically signal cars leaving the toll plazas into the best lanes. And it will begin to warn drivers of impending sudden stops even before a human observer could have detected a problem. The system can be expanded to include the command and control of emergency vehicles and the automatic detection of weather hazards. Presently, Sperry is cooperating with the Highway Research Board in studying the automatic detection of fog on a roadway. The turnpike driver will benefit from these innovations by traveling in increased safety and comfort with minimum delay. Soon, the federal government and the District of Columbia Traffic Department will be operating a special, highly instrumented laboratory system in Washington, D.C. The information and techniques developed with this system will be made available to traffic engineers throughout the nation. The Sperry Traffic and Transportation Systems Group is pleased to have been selected as systems manager for this project. Here at the group's New York facility, the Washington System Computer Center has been installed, and its programs are being checked out prior to actual installation. This procedure reflects Sperry Systems management know-how. Experience on other major systems has shown that as much as 80% of systems integration problems normally encountered on installation can be solved before delivery. Soon, more than 100 intersections in downtown Washington, D.C. will be under computer control to ease traffic congestion, speeding along tourists, diplomats, and townspeople alike. Here in the historic Georgetown section, drivers will be aided by sensors which will provide the needed information to permit the computer to reduce slowdowns and frustrations. 100 years ago, mule-drawn barges carried goods up and down this canal. Soon, cars will flow along the nearby streets assisted by computer. Various experiments and control strategies will be conducted, aimed at helping traffic engineers throughout the country to meet the challenge of increased traffic congestion. Federal programs such as Topics will help finance upgrading of city, county, and state systems. Sperry will participate by assisting traffic engineers with its unique systems approach, moving from concept to full operation. Each system is engineered to the specific requirements of the particular locale. The most effective hardware and software available will be configured to do the job.
I checked the whole and advanced signals at that controller. Okay, I got the pulse.
Sperry support is available from central system installation to integration and checkout of street or highway equipment, to the expansion of the system to include such services as real-time routing of emergency vehicles. The challenge is clear. Modern technology is providing some tools, but it is up to the traffic engineer. We at Sperry are ready to provide whatever help we can.